The transportation of bulk liquids and liquefied gases requires a very specialized piece of equipment. It must be strong, yet light. It must be capable of meeting varying climatic and operating conditions. It must be of such a size as to be conveniently handled mechanically by land, sea, or rail to destinations around the world. For transporting hazardous substances, it must meet strict international regulations governing its construction and use. These requirements are fulfilled by the portable tank, and built into an International Standards Organization ISO container frame as a tank container, it can meet all the handling needs of containerization. The origins of the portable tank go back some 30 years to the revolution in cargo handling methods that took place in the 1950s. The coming of the container, a transport box which could be readily accepted by road, rail and sea, transformed the handling of goods, including liquid cargoes. This museum ship on the Elbe in Hamburg was one of the earliest container ships, and up on the deck we can see a container not dissimilar in appearance to those of the present day. Soon the first purpose-built tanks appeared, and the container concept was adapted to carrying portable tanks, which proved efficient for the transport of products such as whiskey, wine, beer, edible oils, fats, lubricants, and various chemicals. And there evolved a whole range of portable tanks and tank containers built to International Maritime Organization standards, and as detailed in Volume 1 of the IMDG Code under 13.1.2.13 and following numbers. A more recent development is the swap body, developed to suit the needs of some industries, especially on short international journeys. These may depart from the International Standards Organization, ISO standards, in that in at least one plane, the tank frame may have different dimensions. In this case, the tank is longer and wider than normal. In another variation, a tank may only have container fixing and lifting points at the base. Many portable tanks are fitted with ancillary equipment, sometimes as part of the tank, such as valves or framework, and sometimes as accessories, including pumps, compressors, refrigeration, heating, sterilizing equipment, and hoses. As tanks and containers developed, the specialized cellular ships of today arrived, capable in some ships of holding more than 3,000 containers. And on this ship, we see they're stacked several tiers high in the hold. Any portable tank used to transport a dangerous substance and taken on or off a ship is subject to the provisions of the IMDG Code. This applies if it is in a tank container or not, or on a tank vehicle, or transported at sea by any means. With foresight, in 1965, the Intergovernmental Maritime Consultative Organization, IMCO, now the International Maritime Organization, IMO, began to develop Section 13 of the IMDG Code, covering the construction and operation of portable tanks and tank containers for international marine transportation. The code recognized that portable tanks and tank containers would be used to transport hazardous cargoes, such as flammable, toxic, corrosive, or liquefied gas, and so on. Section 13 of the code says that tanks should be designed, manufactured, and tested in accordance with a recognized pressure vessel code. Thus, to enable portable tanks to be used anywhere in the world, tank manufacturers are obliged to comply with these codes, recognized by maritime competent authorities in many different countries and in accordance with other international and national regulations. Portable tanks, as we've said, must be built to approved design, and this is of especial significance where the tanks are designed to carry dangerous substances. From the moment the building of a portable tank begins, a quality assurance document is raised, which follows the tank through the entire production process. This is subject to inspection by an independent surveyor recognized by the competent authority. The forming of the barrel is a fascinating process, as you see here, the cylindrical shape being accurately and skillfully controlled. Quality-checked mild and stainless steels are the principal materials used to form the tank barrel and ends. Automatic welding methods are employed for most of the joints, but skilled welders take care of more intricate sections of the tanks. Meanwhile, almost continuous checking takes place by independent inspectors at various stages of construction. Dye penetration tests are employed, and also X-ray examination of the welds. The documents are now being updated. The tank cylinder is being lowered onto the ends and spot welded. In the main works, a tank is almost ready for delivery. Section 13 of the IMDG code specifies that linings must be immune to attack from the substance to be transported. In a tank such as this, rubber or lead are sometimes used as lining materials. Pressure relief valves are carefully checked before being fitted and during the life of a tank, and must conform to IMDG code requirements. Bottom discharge tanks should be equipped with two independent shut-off devices mounted in series. These consist of an internal stop valve and at the end of each discharge pipe a sluice valve or a bolted blank flange. For certain substances, bottom discharge tanks must be equipped with an additional external closure. A completed tank will bear plates in accordance with the IMDG code. These must be of rust-proof metal on which is stamped in characters at least 3 mm in height the country of manufacture, the IMO tank type, the approval country and number, the manufacturer's name or mark, the tank registration number, the year of manufacture, and the test and maximum allowable working pressures. Other information includes the maximum payload of the tank material, the lining material, if any, the capacity of each compartment, and later on the month, year and pressure of the most recent periodic test, and the stamp of the expert who carried out the test. A tank which falls within the definition of tank container may require an additional plate for the framework, the CSC plate, the Convention for Safe Containers plate. A customs plate certifies that a tank satisfies international customs regulations, which ensures that it can be securely locked and sealed, is tamper-proof, and has no concealed spaces. Exporters of dangerous goods are legally responsible for the correct packing, labelling and documenting of their consignments. The IMDG code requires that information about the hazardous contents of the portable tank or tank container is shown on placards attached to the tank. Labels and placards are assigned to each class of dangerous goods defined in the IMDG code and denote the hazards involved by means of colour and symbols. The proper shipping name and the United Nations number of the substance being carried must be shown. 4 placards, each containing the relevant symbol and class number, must be displayed on either side and on each end of the tank. The United Nations number for the substance must be shown either in the lower half of the diamond or on an orange plate adjacent to the placard. On this tank we have the UN number shown both ways. This tank is carrying ethylene diamine, a Class 8 corrosive liquid with a flash point of 34 degrees Celsius, which can cause skin burns and severe damage to the eyes. We see the placard, UN number, and the proper shipping name of the substance. Below we see a subsidiary risk label. Before shipment, the exporter or consignor must assemble all the relevant information required by the shipping line and the code. Because the transport of dangerous liquids and liquefied gases is a very specialized operation, the first contact will normally be made with a tank operator. Using the IMDG code, the shipper must complete the mandatory International Dangerous Goods Declaration. In many instances, the shipper will be an independent tank operator, who in turn will have to obtain information from the chemical supplier or manufacturer. Dangerous substances suitable for carriage in portable tanks are listed in an appendix which follows each subsection of Section 13 of the IMDG code. Referring back to our tank of ethylene diamine, we see how the shipper or tank operator finds his information from the IMDG code. United Nations number 1604 is shown as Class 8, requiring a subsidiary risk label, flammable liquid. It must be carried in an IMO Type 1 tank. Section 13 shows that a Type 1 portable tank must be fitted with pressure relief devices and have a maximum working pressure of 1.75 bars or above. In this case, the tank must have a minimum test pressure of 4 bars, as specified in the code. The meaning of B in the column headed Bottom Openings is ascertained by consulting Section 13.173. This states that the tank should be equipped with 3 serially mounted and mutually independent shut-off devices, as we've seen earlier. Finally, the IMDG code specifies a minimum tank shell thickness in mild steel or the equivalent in other materials. Certain substances must only be transported in very strong tanks. Motor fuel anti-knock mixtures are one example. Such mixtures come under Class 6 poison, and anti-knock requires a subsidiary risk label showing that it is also a flammable liquid with a flash point below 61 degrees Celsius. From the code, we see that it should be carried in an IMO Type 1 tank with a minimum test pressure of 10 bars. The letters NF in the pressure relief device column indicate that a spring-loaded pressure relief device is required, preceded by a frangible disc. The space between the disc and the valve must be fitted with a pressure gauge or suitable telltale indicator to detect disc rupture or leakage. C in the code indicates that no bottom openings are allowed. Special requirement B states that additional self-contained breathing apparatus is to be provided. Here we see a closed system top-loading and discharging tank with the workers wearing protective clothing and breathing apparatus. Other workers should keep away from the loading bay. Many tank container operators provide a document carrier in which a safety card is stowed. The card is primarily intended for road transport and contains advice in handling material, how to deal with spillages, fire, and first aid. Here we see another loading operation of a flammable liquid, acetone. Before loading, the vehicle is earthed by means of this clamp. If not properly earthed, an alarm sounds. Close by, we see eye wash facilities and emergency shower. Obviously, strict no smoking regulations are in force at this depot, and no one is allowed to carry matches, lighters, or any apparatus, such as Walkman receivers, which could produce sparks. Every driver employed in the transport of hazardous liquids must have attended an approved training course. In Europe, this is an ADR requirement. The handling of extremely low temperature liquefied gases is another specialized use of portable tanks. Here we see a cryogenic portable tank containing liquefied argon at a temperature around 180 degrees below 0 Celsius. Special protective gloves are worn and everything is insulated, but even so, ice soon forms around the connecting pipes. But back to portable tanks in general. Some considerations have to be taken into account when filling them, whether they are in tank containers or not. Portable tanks should not be underfilled or overfilled. They should never be offered for transport in an ullage condition liable to produce an unacceptable hydraulic force due to surge within the tank. In selecting the right type of tank to use, account must be taken of this factor. The maximum filling levels are specified in the code, page 0059, and take into account the filling temperature and a theoretical maximum temperature of 50 degrees Celsius. The shipper must be able to supply the specific gravity of the liquid at these temperatures. Failure to allow sufficient ullage is dangerous. Temperature control of some substances transported in a tank is sometimes required, and where heating or refrigeration is used, the carriage temperature should not exceed or fall below the design temperature range of the tank. When portable tanks are to be refilled with a substance different from the last one transported, they must be thoroughly cleaned internally before being refilled. Here we see the cleaning operation in progress. The IMDG code says that empty tanks not cleaned must be treated as if still containing the dangerous substance, and consideration must be given to the disposal of cargo residues. Cleaning staff should not start work until they've received precise instructions. When the tank is clean, the warning labels and placards must be removed or covered over. The portable tanks are now going on board a roll-on, roll-off vessel. But before this can happen, the shipping company must be in possession of all documentation relating to the tank and its contents. If the list contains dangerous goods information, the list should be circulated to the port authorities and all departments involved in handling the tank, including the shipping clerks, quay foreman, and the ship's cargo officer. Information may also be passed to the local fire brigade and the police when practicable. The IMO has provided, as a supplement to the IMDG code, 2 booklets. One is the Medical First Aid Guide, known as MFAG. The other is the Emergency Procedures for Ships Carrying Dangerous Goods, the EMS. The general or numerical index in volume 5 of the IMDG code tells you how to obtain precise information from the guides in an emergency. Detailed information on this subject is contained in the films Dangerous Goods at Sea and The Handling of Dangerous Substances in Port Areas, parts 1 and 2. Segregation of dangerous goods is essential on board ship and in port areas. At this port, for instance, the authorities like to keep a Class 3 flammable liquid and a Class 8 corrosive at least 5 meters apart, and a Class 3 and a Class 5 oxidizing substance at least 10 meters apart. On board ship, portable tanks containing hazardous cargo must be treated in exactly the same way as other dangerous cargo. Similar stowage and segregation principles are to be observed as shown on page 00611 and 00612 of the IMDG code. On ro-ro vessels, the normal method of operation is for a portable tank or tank container to be taken off a vehicle at a port and to travel on the ship as ordinary cargo, perhaps mounted on a ship's trailer. The type of trailer employed must obviously be appropriate for the type of tank and take into account the methods of securing the trailer to the ship. It is essential that all tanks and tank containers are properly secured on board ship. At the end of the journey by sea, most portable tanks and tank containers will be kept in the port area until arrangements are made for them to be collected. Some port authorities may insist that tanks containing hazardous substances are loaded last and unloaded first. On the ship, they will, according to the hazard, generally be stowed on deck and segregated from other cargo. Most container terminals operate lift-on and lift-off services by means of quayside gantry cranes, and the containers may be brought to the crane by straddle carriers. To avoid the possibility of accidental damage by a straddle carrier or other handling equipment, drivers of tank vehicles and those carrying tank containers must obey the routing and parking regulations in the port. For pedestrians, a suitable system of signs and markings may be painted on the terminal, segregating the pedestrians from the vehicles. All work must stop when winds become excessive. In this terminal, drivers of cranes, carriers and mobile lift trucks are in constant radio contact with the terminal operations room. Hard hats, high visibility vests and safety shoes should be worn at all times. The introduction of portable tanks and tank containers has transformed the carriage of bulk liquid cargoes, both hazardous and non-hazardous. Their development, carefully controlled by international experts, has ensured that only the best and safest equipment is produced by manufacturers. Codes of practice have increased safety and efficiency beyond measure and are constantly being reviewed and revised to meet developing demands. Nevertheless, because of the possibilities of emergencies on the road or in port, it is wise from time to time to have emergency drills, as if an incident had occurred. Here we see a team simulating the transfer of a dangerous liquid from a leaking tank to a sound one, and all procedures and precautions are employed as if the liquid were hazardous. It is all part of being prepared. Portable tanks and tank containers will continue to serve industry and mankind, and it is up to those who work with them to help maintain their enviable record of efficiency and safety.